today's community office hours is about Pulumi and Garden's Pulumi plugin, which we made in Q1. And which we've been sort of it's experimental, but we've been sort of incrementally tweaking and refining it with one of our customers who's kind of a power user, which is great. I mean, because you sort of can't get these things right without having a real use case in mind. So we'll start by covering what Pulumi is, what it does, what the sort of how it fits into the landscape of things. Then we'll have a brief summary of how it works, how it does what it does. And then we'll proceed to Garden's Pulumi plugin, why it was needed, so what was the motivation for it, what benefits it adds on top of vanilla Pulumi, and then some kind of general takeaways from the experience of writing the plugin and what that tells us about plugins that should be written in the future. And there's also some interesting things about the workflows around reviewing plans before deploying them. That applies to yeah, that could be interesting to abstract into the framework level, which we'll be having a serious look at later. But anyway, let's just dive right in. So what is Pulumi? Pulumi is fundamentally a deployment tool. It's commonly sort of located as an infrastructure as code tool, but when I say as code, I really mean code. So this means you know the default is to use a full-powered programming language, not a config language, when you do your Pulumi stuff. And I lifted the screenshot here of Pulumi's website. As you can see, there is a YAML option, but that's not really why you would come to Pulumi. So whereas like with Terraform, you would have a configuration file where you say, you declare an S3 bucket, a Kubernetes cluster, Kubernetes resources, and a database, whatever, and then apply the stack. It's still basically their data structure literals with expressions in them. That's kind of all you have. There's no function. There's no kind of, you can't like define a function and reuse it elsewhere, as far as I know. Whereas like in Pulumi, it's just like a TypeScript program. So they're called programs, not stacks. Well, they're called stacks when they're deployed. And so the way it essentially works is, for example, here in the example, a S3 bucket is being created. And the way that's done is like you have these kind of magical classes from the Pulumi SDK where if you allocate an S3 bucket object with certain attributes, through some magic mechanism, Pulumi ends up kind of picking up everything that was created. And at the end of the program, that's kind of what you asked for. So all you got to do is kind of declare these things. But you can import helper functions. It's a full-on program, and you can do things that are not just configuration. For example, this customer of ours who's using Pulumi, one of the reasons they're using Pulumi for deployments is that you can do things like, for example, read a configuration file that the user generates or user provides, do arbitrary scripting on that, feed that into the deployments without having to sort of script in a separate tool. It's like a full-powered, you can really make use of that in some cases, and yeah. So again, you use a full-power programming language to declare your infra and your deployments. So the pros and cons of this, I would say, is that, well, the pros are programming languages, the Turing complete programming languages are powerful. You get abstraction and code reuse instead of these sometimes repetitive, hard to read, arcane configuration expressions you get in configuration languages where you have repetitive patterns. There's no simple way to abstract them out. If you have a lot of stuff going on, a lot of dynamism, there's no way to like extract that out into data, helpers, have unit tests for the helpers. Like all of the methods that we, the methods we use for software engineering in general, like again, abstraction, code reuse, testing, are a lot easier to get at when you're using a programming language. Another pro is that like you can still render out, for example, concrete YAML, concrete configuration, like for example, Kubernetes manifests, if you want to pass that off to a security scanner or some other tool that expects a fully rendered config. So it's not like, you're not really sort of like letting go of the static analysis abilities either. And finally, developers often prefer writing programs. So this is, I think it's also partly marketed at people like people who prefer writing code to config files. Whereas the opposite is often true of SREs and DevOps engineers who prefer or are kind of maybe more used to configuration files. Now, the first and main drawback of Pulumi is the flip side of the main upside, is that programming languages are powerful, and that's scary and difficult. Because when you see a config file, it's a data structure literal. That's literally what it is. It's just a nested data structure, and it's just right there. It's right there. And for the simple cases, like you can usually reason relatively locally about what you're seeing. There's not a lot of interactions between different parts of the code. It's kind of very explicit. And for the simpler cases, when there's not a lot of dynamism or code reuse needed, it is like simpler to reason about, maybe. Where I think that's probably the reason why, for example, Kubernetes opts for having YAML for its configuration rather than something like this. And I would say probably, I mean, I've not used Kubernetes in production myself, but like if you had a bunch of people working on these things, like you probably need to have some discipline on the team level to avoid this, becoming a giant ball of, well, only Susan knows how the deployment stuff works because she wrote this stack and it's a work of art, but nobody can really untangle it, and it's really scary. And if you change it, like it's gonna break. And so there is that part of it, like with some, this sometimes happens with code bases, of course. Like they develop to the point where it's hard to onboard people. There's tribal knowledge, there's knowledge that's embedded in a few individuals, and there is some benefit to like, it's crafty, it's repetitive, but like you can bring in a new operator and they can sort of get in there and understand it. So there is like, I can imagine that more disciplines required to sort of keep it at that level. Now, how does it work? So essentially, like as we saw on the screenshot earlier, you use the Pulumi SDK in a programming language of your choice. Well, they basically support some of the most popular programming languages like JavaScript, TypeScript, Python, Go, a few others. So you declare resources with the Pulumi SDK. So in that program, and the program is basically like, well, a code file that is run. And Pulumi runs that, and we'll get into the flow of that later, how that works. And stacks are kind of that's kind of a concrete instance that's deployed. An instance of a Pulumi program that's been deployed with concrete configuration. It's live. Kind of like a stack is a container and a program is an image. To make an analogy with Docker. Similarly to Terraform, programs can use stack references to read runtime values from other stacks. So let's say, for example, you're deploying a API service that needs to connect to a database that's provisioned on an RDS, and you want to pass in the concrete host name and any other sort of connection parameters that get generated at runtime, maybe an IP address or some other piece of network configuration that's not known until you deploy it. You can read that in, and then so Pulumi comes with a cloud backend, which you can query for these stack references, and you can bring your own, but the default is for you to subscribe to the cloud API backend where they provide this as a service for you. And it's also really nice in that like you can see a history of the deployments, you can see the diffs. It's kind of a pretty nice baked-in experience there. A lot of these concepts have analogs in Terraform, and I think Trip pointed this out to me the other day. Like, in a way, it's a little bit like the split between Puppet and was it Chef back in the day, where one of them, I never remember which was which. One of them was more codey, and the other was more configury. And there's always going to be those kind of two camps of people. Which flavor do you prefer? But it kind of makes sense that like well-designed systems will discover similar patterns in a lot of ways. So some of these concepts will have analogs in Terraform, and I imagine if you already know Terraform, you would have an easier time picking up Pulumi. So how it all comes together, what actually happens when you run Pulumi App or Pulumi Preview. So Pulumi App is like the analog to Terraform Apply. It's how you deploy the stack. Pulumi Preview is like a dry run that sort of prepares a plan, gives you a preview of the changes that would be applied if you ran Pulumi App. When you're doing sensitive stuff, you would often run a Pulumi Preview before you run the Pulumi App, just because you want to vet the changes before you make changes to sensitive infra, stuff that could be destructive. And so first off, before you can run the Pulumi program and evaluate that, you need the inputs. And those are the stack configs. Oh yeah, I forgot to mention those on the previous slide. So stack configs are basically YAML files with like, let's say you have a dev environment, you have a prod environment, you have a staging environment, and you maybe have some different key value pairs and different data for those. Those are also, those can also feed in there. And for people who are familiar with Garden, this is a little bit analogous to the environment specific variables that you can feed in. But anyway, you read in the stack config for the environment, for the stack you've selected. The stack you've selected is like, I'm in the dev stack and so forth. Read those in. You also read it in the stack references. That happens when the program is executed at runtime. And then you have all of the inputs you need to evaluate the Pulumi program. At the end of that, you have a bunch of allocated resources. Like, here's an S3 bucket, here's a Kubernetes deployment. They have these concrete fields populated. And then you have a list of resources generated from the program. This list is then diffed with the deployed stack, if any. If not, it's all new. And Pulumi is able to sort of figure out like, okay, these are the changes that will be made. So in that way, it's pretty similar to the Terraform plan thing. This plan is then, depending on which CLI commands you call, this is then summarized and presented to the user, or it's applied immediately, or there's a confirmation prompt. But yeah, basically it is like, get the inputs, diff it, and then like, all right, I would do this. Do you want to proceed? And then it can apply those things. And then the cloud backend is kind of used as the sort of state synchronization piece in there. So why do we need a plugin around all this? So this was originally requested by a big enterprise client of ours who have like 30 plus services, Pulumi services in their stack. Some of that is infra, but a lot of it is just like, a bunch of services that is like maybe not a microservice stack, but a multi-service stack. It's a serious backend application. And the thing is, like, running Pulumi preview is pretty expensive. It costs a lot of RAM, costs a lot of CPU. It takes some time. You're running through the program and you're diffing it. You're doing a lot of work. Even just preparing the resources for the diffing is not cheap. And even the automation API from Pulumi is ultimately calling the CLI. And if you want to do like, you have like, imagine that this here is the dependency graph here on the left. If you're running that like 5 times in parallel, that's going to eat up a lot of RAM. Like you're running a big runtime, you're spinning that up like several times in parallel. That's going to put some strain on your CI system and so forth, and it's going to take more time than is necessarily necessary. The beauty of it is that like Garden's versioning system, which is kind of dependency aware and factors in source code versions and the fully resolved config version. The documentation points the user towards representing all the stack references that are used in the program in the config, and then you can basically rely on the service version that is generated by Garden representing like has the stack changed or not. And we'll get into how this is implemented, but the TLDR of it, we'll look at the implementation on the next slide. But the TLDR is that we can do lightning fast incremental deploys because we only have to make a single web API call to figure out like has the service version changed. If it's changed, then okay, we got to proceed. But for incremental deployments, you can really do them a lot faster than is possible with vanilla Pulumi. Again, because vanilla Pulumi doesn't have this versioning thing and the graph awareness that Garden has. The Pulumi plugin is quite a thin wrapper on the Pulumi CLI. And it's really just like making smart use of the graph primitives and the versioning primitives that we already have. And you also want to be able to deploy in dependency order, which is something that Garden is great at. Another thing is that Pulumi has a CLI option for deploying from a pre-generated plan. So this is something that Terraform has had for a long time, where you can like, I only want to apply precisely the things that are in the plan, and I can pre-vet that. And the tool assures me that nothing is going to happen if it hasn't been, only the things in the plan get applied. And so, if you use the Pulumi experimental true environment variable, you can see this option, you can use that. But this is also, part of the motivation here is like, they want to have a code review process around show me the diffs for only the Pulumi services that have changed. I can click into the Pulumi web UI and see those things, but sort of give me a graph level summary and diff those things and provide me with, let me make use of Garden's templating facilities. And the Pulumi plugin in general kind of makes it easier to implement this sort of review and approve before deploying flow. So the joke here is that that Pulumi's mascot is the Pulumipus, which is a platypus. So we try to make the Pulumipus run a little bit faster, which we do. And the TLDR of it is that we use stack tags to store the Garden service version. The stack tag is basically just like, a metadata annotation, like it's a key value pair that you can set on the running stack that is stored in the Pulumi backend. So we're using the Pulumi backend as a key value store there. Then we can just see, like, every time we deploy, we set the Garden service version on the stack tag. And then before we deploy, we see, is it deployed? If it's deployed, let's read the service version from the stack tag. If it's the same, we can skip. We don't have to run Pulumi preview, and that's how we make it super fast. And again, that was super easy to implement because all we got to do is use a service version. And that's kind of one of the takeaways, which we'll get into later, is like anytime where you have, when there's a way to share versions to store that state, you can get these fast incremental redeploys with any deployment tool with Garden kind of out of the box. And any time where you're having slow incremental redeploys with a deployment platform, there's real value in considering a Garden plugin. So that's that. Number two, the planning flow. So when you have a lot of services, first of all, Pulumi doesn't have any concept of like run this for all the services in the project. And then like most of those are no ops, so it's not like as a reviewer, what do I have to review? Which plans are not no ops? Like show me only those. So you need that kind of graph level summary. And you also need to be able to deploy from plans only for the whole graph. So graph level previews, a graph level summary, and then a graph level deploy. And so we have plugin commands. So commands that are specific to the Pulumi plugin that utilize the stack graph. For example, the Garden plugin Pulumi preview command will walk through the graph in dependency order and generate the previews. And then that gets stored in the directory. There's, in the .garden directory, there's a separate directory that shows you only the change plans. And, just some niceties to make it easier to pass it off to later automation and or to build a sort of a bit more of a full-bodied CI process around this. But eventually what we want to do is to fold this into a Garden plan command. So this is almost like a prototype of the Garden plugins Pulumi preview command is a prototype of what we want to do for Garden in general, which is this kind of flow where you want to like, here's a plan for deployments. Maybe for certain services, you only want to deploy after approving them, like, sensitive services, databases, or I don't know, like certain services that are flagged like as sensitive. And you want to be able to do that in a cross-platform kind of way. So, for Kubernetes, you would see the Kubernetes manifest diffs. For Helm, you would see the diffs of the Helm charts. And for Pulumi, you could see the plans. And all you have to do is to define the plan deployment action for that plugin, and then we could represent that in the Cloud UI or if only like a textual summary in the plan command. So this will eventually get folded into that once that's released. But this is already making the review process for this big enterprise a lot easier. Just a lot easier to sort of grok, like, what do I need to review? What are the things that were actually affected? And then you just click and you look at the Pulumi web UI. But what we are doing is we're adding the graph level view on top of things, which is kind of out of scope for Pulumi itself. But I actually talked to the Pulumi folks at a conference in Seattle that Trip and I went to. And I asked them, like, is this typical that people have like 30 stacks? I was like, yeah, it is. So it does sound like this is not just like not just something that's appropriate for like a giant ass enterprise. It's also sounds like it could be useful for a lot of people who are using Pulumi for the deployments. Let's do a quick demo. I'll just do Garden plugins Pulumi preview. I'm inside the Pulumi example project here. This is running on my local Kubernetes. So it's going to go through, we have two services in this project, the Kubernetes namespace, which deploys the Kubernetes namespace, and then a deployment, it creates a basic deployment in that namespace. And you see here the namespace is already up, doesn't need to be deployed. And then so the deployment is unchanged, but the namespace would be changed. So that's that. And also here we see in the .garden Pulumi outputs, we see there's a cache here of the last preview, and the modified directory contains a copy of only those plans that have changes in them. Last preview modified. You see, this is pretty verbose. So you generally wouldn't read that here. What you would generally do is you would go into, the Pulumi web UI. Oh, I'm signed it as the garden bot. I'm not going to do that now. But you would see, the nice web UI for the actual diffing. So there's garden deploy as well, which is, again, these are just services. You can mix and match them with anything else. So all we really had to do to make this plugin was, make a very minimal module configuration. Let me just actually. So here's the stack config. And also a nice thing about the about the Pulumi module is that it merges in. You define these variables, for your garden module, and those get merged into the stack config. So basically, it kind of plugs your garden template in context, it merges it together for you, so you can sort of feed that in from the outside, and with var files and everything. But it's essentially a very thin wrapper around the Pulumi CLI, it's being used to deploy the production. Simple as it is. Sometimes all you need is a little bit of added context on the outside to really improve things. And it's like this stuff is kind of out of scope for just Pulumi, because Pulumi is like, I'll deploy your stack for you. It's not a tool that says like, I understand projects full of stacks. That's just not their deal. They're a single stack at a time kind of deal. So it's almost a perfect companion for the graph level piece for any kind of Pulumi project. So the lessons learned is that, again, I kind of covered a lot of this already. The versioning capabilities made it quite easy to implement the fast redeploy. So all I had to do is like, okay, where can I store the version? Is there anything in the backend that can do that? I was like, oh yeah, stack tags, and then that was that. And that's like really easy. And for any plugin, if you have a key value store available, at all stages, you have that. All you got to do is make use of that in the plugin. Writing the plugin itself was pretty straightforward. The tricky part was the back and forth with the customer who had the actual use case. Like, is this how you're using it? Does this make sense? And if I just sat next to them for a week, we would have gotten it done in a week, but instead it took 3 weeks. So that's that. And that kind of like raises the point that like we really need to get our plugin SDK out to make it easier for people who like, I'm using this tool, I know exactly how it should be used. Just let me add it. Let me write my own verbs. That would, like, but right now it's kind of hard to do this if you're not a core contributor. But I think there's like a lot of latent low-hanging fruit out there that I hope will mature into plugins once the SDK is out. But I think that we'll have to look into that in Q4 or Q1. So that is that.